Hello! Welcome back to assignment set B. It's pretty fun stuff. For topic B.2, the second and last topic of the week, we will look at sector area, and we'll talk about how that is similar to and different from what we did with arc length. So once again, this page is going to have live links by the time it goes out to you. So our job is to find area of sectors and then kind of work forward and backwards, very much like what we did with arc length, just kind of finding a different thing. You'll have notes. This video will be linked, and then we'll also have filled out notes in PDF form. Homework, Mr. Burton made those videos. There are 2 videos for this homework, one for the first part, one for the second part, and then just a quick check answer key and then a check-in as before. So this video is just going to be for the notes, and what you'll see is that it pretty much is going to work the same way that we did arc length stuff, and then we'll just be working through some examples at the end. So nothing too crazy going on. Let's take a look. So the formula for the area of a circle. Here again, I mentioned this very briefly in the A.2 video from last week. And then we didn't really use it in that topic, but I wanted to introduce it. So here it is again. Formula for the area of a circle has a pi, because it's a circle, and then radius squared. The stupid thing that I've said, I don't know, 50 times at this point in these videos, is the stupid made-up word squarea, that if I'm dealing with area, I'm going to be squaring something. I'm either going to be thinking about square units, or in this case, I'm actually squaring something in the formula. To contrast that with circumference. So circumference is 2 pi r. Both of these have a 2 in them, but for circumference, the 2 is a coefficient in front, whereas for area, the 2 is an exponent. Both of them have a pi, and of course, both of them involve the radius of the circle. So just to contrast it with what we did for circumference, there is a pi, there is an r, and there is a 2, just that 2 is doing something different for area than it is in the circumference formula. So as we did with the others, just a few examples before we start slicing the pizza up. Let's just deal with full area. So find the area of a circle with a radius of 5 feet. This is just a straightforward using the formula thing. As I said in the previous video, it is going to be really helpful as these problems start to get more complicated, just to write the formula down exactly as it appears before you start plugging stuff in. Then read through your question again, see what it told you. The radius is 5 feet, so that's going to go in obviously for r. So I have pi times 5 squared. On the blue and white calculator, you can type it in with the pi button, but you don't really need to. Just focus on everything else. 5 squared is 25, and oh yeah, we were also multiplying by pi. So 25 times pi is your exact area. And then the toggle button on the calculator, if you have the blue and white one, turns it into a decimal, 78.54. And again, if you're getting the exact version from your calculator, hit the toggle button to make a decimal. And since this is area, the units are not going to be in feet anymore. The units are going to be in square feet. So the squaring did 2 things. It literally squared the 5 to turn it into a 25. It also is a way of remembering we need square units here. Okay. Find the area of a circle with a diameter of 8 centimeters. Nothing too crazy. We're looking for area. So that's pi r squared. And then we read through again. So if the diameter is 8 centimeters, then the radius is half that. It's 4. 4 squared, 4 times 4 is 16, and that's getting multiplied by pi. And if we put that in the calculator, 50.27. And since this is an area answer, That would be measured not in centimeters, but in square centimeters. So centimeters squared, or you could write just the abbreviation, square centimeters. Okay. And then working backwards. So this time I told you the area, and I'm trying to figure out what the radius is. But the fact that I told you the area tells me to start here. And so then area is what we were given here, that 43 square inches. That's pi r squared. Notice that, so sure, it says inches squared or squared inches. That doesn't change the math that we do. It doesn't change the 43. That's just the way units work for area. So down here now it's our job to solve this equation. I need to get rid of the squaring, but before I can do that, I need to get rid of this multiplication. So I'm going to divide both sides by pi. And this is where different calculators are going to do different things. So I'll be a little bit more lenient on the rounding stuff here. If I go ahead and round to 2 decimal places, that is okay. I'll talk about a different option that your calculator might do later. Then we're ready to get rid of squaring, which we've done before. I want to take a square root on both sides. So square root of 13.69 gives me 3.7 on the nose. If you wanted to write a second decimal place, you could certainly do 3.70. Another possibility, I don't really think it's worth it, honestly, but you could, after we get to this 43 equals pi r squared, you could just write down your steps. I'm going to divide by pi, and then I'm going to take the square root of that, which I did in green. Of course, color coding is important. On the blue and white calculators especially, if you just use your fraction button to type in that 43 over pi rather than this 13.69, you're going to get like a slightly more accurate answer, 3.69963851. But in this case, and in most cases, honestly, after we round that, we're going to get the same answer. So if you want to keep everything like really, really accurate and perfect, fraction button will take care of it. But if you round along the way, it's not ideal, but it's fine. So that was for the area of the full circle, pi r squared. If I want the area of just a slice of the pizza, then I'm going to do essentially the same thing we did with arc length. But instead of comparing it to circumference, we're going to compare it to the area of the whole circle. So one way of thinking about this, I'm going to do SA for sector area, is to say the area of the whole circle is pi r squared, right? We just saw that. But I don't have the entire circle. I only have my little slice. So I'm going to make a fraction. Out of 360 degrees, my slice has theta degrees. There's that symbol again. Theta is just something measured in degrees. So whether it's the central angle of your pizza slice or the measure of the arc, it's just something measured in degrees. And you'll notice, hopefully, that this looks an awful lot like what we saw with arc length. 2 pi r theta for 360. The only difference is that for arc length, that was part of circumference, so we use circumference. Sector area, rather, is part of the full area, so we did pi r squared instead. Same idea. And just like sector area, you have another option if you prefer. The area of my slice, or of my sector. That's my part of the area out of the entire area of the circle. And that's going to be the same as the fraction, my degrees over the full degrees, 360. Here again, if you compare it to this version of arc length, we did arc length compared to the whole circumference. equals my angle out of 360. So the arc length was part of circumference, so we use 2 pi r, but now sector area is part of area, so we use pi r squared. So it looks like we have like a bunch of different formulas, but they're all really basically the same thing. So the rest of this is just going to be getting some practice with these. And the first one, these numbers hopefully or should look familiar from the previous one. But this time I'm not interested just in this arc. Instead, I'm interested in this entire shaded area. So find the area of the shaded sector. The word area is what tips me off that I'm going to go with one of my area formulas. As we did before, I'll try it with the first version of the formula, and then I'll try another with the second version, and you can do it whichever the heck way you want to. It doesn't really matter. But what is important is that I don't use the arc length formula. They're asking me about area, so I need a pi r squared to show up. If I'm talking about sector area, even better, I'll call it SA. But I definitely want pi r squared rather than 2 pi r. Then we start plugging stuff in. 5 centimeters is the radius of my circle. 76 degrees is measured in degrees, and that's all it takes to make that theta. So sector area, we don't know, but pi times my radius squared times 76 degrees out of 360. And here, the thing that we don't know is already by itself, so this is already just a job for the calculator. What I'm going to do is just deal with the nice pretty numbers to start with. And that gave me, I have a graphing calculator, so it gave me a weird decimal. If you have the blue and white, you're not going to have to worry about it. And so on mine, forget what I just typed, I'm going to hit math, enter, enter. And it gives me a fraction 95 over 18. And then I just say, oh, right, there was a pi there, and we're good. If you did it on a blue and white calculator, it probably put the pi in the numerator. That's fine. And since we're dealing with area, this isn't going to be in centimeters. It's going to be in square centimeters, or you could write it as centimeters squared. Okay. Another example, this is one I'm going to have you try on your own. There are no units here. It doesn't say centimeters or feet or anything, so don't worry about the units. But pause the video and try this one on your own using either version of the formula, and when you're ready, unpause it. Either way that you did this problem, whether it was with version 1 of the formula or version 2 or some other method, you definitely, obviously, should have gotten the same answer. So the exact answer here is 80 pi. And if you approximate that with 2 decimal places, it rounds up to 251.33. In this case, the first version of the formula is definitely easier, just because the thing you're looking for, sector area, ends up being by itself already, and so you just plug numbers in, type it into a calculator. On the other side, where I use the second version of the formula, the thing I don't know is not by itself, and so if I do the cross multiplication trick, it takes a little bit more work in this case, but this method, some people prefer it. And there are other ways you could get from this setup to that answer a little bit faster. There are like a trillion other ways you could do this problem. I'm just trying to show you a couple different options for you to choose from, or do it your own way. You know that that's always fine. Okay. Now we're working backwards a little bit. If the area of the shaded sector is 38 square units, what is the measure of the sector's arc? And let's round to the nearest degree, so the nearest whole number. Really, before I do anything else, I see area of a sector. So that's going to make me think of either of my sector area formulas. I'm going to do the second version, but it doesn't matter. So sector area divided by the full area equals my degrees out of the entire degrees. So just copying the formula and then pulling specific information. The area of the shaded sector is 38 square units. The area of my sector is going to be 38. What is the measure of the sector's arc? Measure of an arc is in degrees. So that tells me that we're interested in finding theta, but we don't know it. What we do know from the picture is a 6, which is clearly the radius. So let's take that information and just plug it in. So in blue, the area of the shaded sector is 38 square units over pi times radius squared equals theta, something in degrees, which I don't know in degrees, out of 360. So from here, honestly, the quickest way to solve this particular equation, worked out this way, is just multiply both sides by 360 and be done with it. But this version of the formula, a lot of students who do prefer this, they kind of prefer it because it's just you cross multiply some stuff and call it a day. So 38 times 360, this is not the fastest way to solve, but cross multiplying something like this just always works. 38 times 360 gives me 13,680. Pi times 6 squared times x. 6 squared is 36 times a pi times an x. And then I divide both sides by 36 first and then by pi as a two-step process. Or if you want to go a little bit faster, you just have to be really careful and group the 36 and the pi together with parentheses to get rid of them both at once. And so that gives me 120.96 for my missing piece. And since this was the measure of an arc, that's going to be in degrees. If you got an answer of, oh heavens, 1,193.81, it's wrong, obviously. We shouldn't have an angle or an arc measure bigger than 360 degrees. What happened here to give you that answer is that you messed up solving that equation. So you thought you were dividing by 36 pi, but what you were actually asking the calculator to do is dividing by 36 and then multiplying by pi. So fraction bar, parentheses, or doing it as two steps is going to help you avoid that mistake. Here, finding the radius of the circle. And even before that, it's not so much what I'm asked to find, it's just that somewhere in this problem I see the word area. Area of the shaded sector tells me to go with one of my area formulas. The previous example I did with this version of the formula, so let's try this guy with the other version of the formula. Sector area equals pi r squared for the full area times theta out of 360, kind of my fraction of the full area. So I just copied the formula. Now let's pull information. The area of the shaded sector is 303 square units. Sector area was given. We're looking for the radius, so that's a thing we don't know. And then theta, something measured in degrees, they gave that to me in the picture rather than the words. So sector area in yellow, that's 303, pi times a radius squared, which I don't know, times theta, something in degrees, is 226 out of 360. With version 1 of the formula, where surface area is just over here by itself, I'm not going to bother cross multiplying because it's just one fraction. I am just going to multiply both sides by 360 360 times 303 is 109,080. In these problems, do not worry when you get giant numbers. It's gonna happen. So then I have pi r squared times 226. And it's my job to get that radius by itself. So in order to do that, I need to get rid of the 226 that's being multiplied. I need to get rid of the pi that's being multiplied. And again, I can do that in 2 steps or 1. If I want to do it in 1 step, I definitely need parentheses, but it's also just kind of safer to go with 2 steps. So I'll deal with that whole number first, kind of leave the pi alone. And so here I have to start rounding. There are ways to be more perfect than this, but being perfect is not really the goal right now, I'll be honest. So we've got this, then I can get rid of the pi. And depending on how you put this in your calculator and depending on what your calculator does with it, you're either going to get this for right now, or... oh, actually it works out the same either way. So hooray. Again, rounding at this step wasn't ideal, but it ended up not making a difference. But we're not quite finished because I'm looking for the radius, and right now I have the radius squared. As we've done a trillion times before, if I have to cancel out squaring, yikes, that is what square roots are for. So my radius, when it's completely by itself, rounded to 2 decimal places, 12.39, kind of either way you do it. The next digit is a 4, and so that doesn't bump the 9 up at all. Okay. And then the final question brings together what we did in the first topic with arc length, and also in this topic with sector area. So they gave me the length of the bold arc. So we're going to start this problem the way we did arc length. So using arc length, we're going to find the measure of the bold arc rounded to the nearest whole number. And then after we have that, then we're going to find the area. So I'm going to have you guys try this on your own, but just kind of some guidance. First job, you're going to use length to find the measure of the bold arc, which is going to be in degrees. And then once you know that, then you're going to be ready to find the sector area. But the reason I wanted to do this problem is because it makes you kind of recap what we've already done. The first part talks about the length of an arc, so use the older stuff. Then, after you've done some work, then you're going to be ready to find area. So pause the video, give this one a shot, at least step 1, hopefully step 2 as well, and then unpause when you're ready. So I chose to do this with the first version of the formula, and so as before, I just copied the formula down, and then I reread the information I had and just put it in the appropriate spot. So they gave me length as 22.3, so that's highlighted in pink. They gave me a radius of 9, and they didn't give me theta. They didn't give me the measure of the bold arc. So I plugged stuff in. I multiplied both sides by 360 to get that to go away. I combined the 2 times the 9 to give me an 18. And then I divided both sides to get the x by itself. Rounded to the nearest degree, the correct answer here is 142. If you got 1,401.15 degrees, first off, I hope you realize that is wrong because it's bigger than 360 degrees. But that, again, would be what you would get if you forgot to put parentheses around the 18 pi or somehow screwed that up. So we've talked through how to avoid that. Go back and view that part of the video. But now that I have the measure of this bold arc, now I'm ready to do the newer thing and find the area of the shaded sector. So now that they're asking for area, I start a new process. Area. I'm going to stick with version 1 of the formula, but it's your choice. Pi r squared theta over 360. And then I just reread. So sector area they did not give me. Pi times the radius they did give me, that is 9. Theta they didn't give to me, but we figured it out. It's 142 degrees over 360. And since the thing I'm looking for is already by itself, this is just a calculator's job. And so, depending on what your calculator says, you might get 639 pi over 20, but this says 2 decimal places, so everybody should end up with 100.37. And since we're looking for area here, or sector area, that would be measured in square inches. Here you'll notice I got a little lazy. I did A for area. Really should have done SA for sector area. That does it for this topic. And so as before, you have a quick check for this topic as well as homework. Also, I just realized just this minute, that second example here, you don't care, but I do. It said round to the nearest degree, and I forgot to do that. 121 degrees is what I should have set up there. But anyways, you have a 3-question quick check again. You have homework. This time I'm only requiring the odd numbered problems. I liked the odds better than the evens, but they're all good problems, so feel free to do as many of those as you want to. And that, once you're done with that, you are finished for this week, and set C will be posted by noon on Monday. Bye, guys.